Let's solve LeetCode 238 product of array except self. So given an integer array nums, we want to return an array answer such that answer at I is equal to the product of all of the elements of nums except nums at I. So what I mean by that is that let's say the input 1, 2, 3, 4 is given. The output is 24, 12, 8, 6. How? Let's go over it one by one. We get 24 because at nums at I, we are skipping this element and we are doing 2 into 3 into 4, which gives us 24. Now 12, how do we do that? We do 1 into 3 into 4. We skip out 2. We do 1 into 3 into 4 and get 12. How do we get 8? We do 1 into 2 into 4. We skip out on 3. And how do we get 6? Think for yourself. That's right. We do 1 into 2 into 3, we skip out on 4 and we get 6. So what we want to do is product of the array except the answer or the nums at I itself. So that's what this question means, product of array except self. Let's understand the restrictions. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operation. So the very first thing that came to my mind after reading just this much was a solution that required using the division operation. How? Let's go over it. I'm just going to go ahead and copy this nums array so that we have better written down. And yeah, red color looks good to me. It's not red actually, I don't know what color this is, but anyways, moving ahead, what we're trying to do here is my first instinct was calculating the total product of this entire array. So I have 1 into 2 into 3 into 4, which is 24. And then what I do is create an array where I just divide by the particular element. So I do 24 divided by 1, which is 24. Then I do 24 divided by 2, which is 12. Then I do 24 divided by 3, which is 8. 24 divided by 4, 6, and that is the answer. Now this is not acceptable because we can't use the division operation despite it being O of n time. So if you didn't have the division restriction, this was a fairly easy, straightforward problem. But let's follow the restriction now. How are we going to solve it? Let's think about it as humanly as possible. How are we going to solve this as humans? What we're trying to do here is we just calculate, let's say for the element 3, all right? What we'll do is calculate all of the things that are present on the left hand side. We'll skip this particular guy and then move to the right hand side. So what we're doing is calculating the products on the left hand side, calculating the products on the right hand side, multiplying both of them, and then we get our answer. That's exactly how we can solve this problem as well. We can create two arrays. The first array is going to be a left hand side array. Let me just call it LHS. And then you have a RHS, right hand side products. And these are both arrays. Then what we can do is calculate the products of the element to the left. So for example, to the left of 2, we have 1. The product of all of the elements left to 2 is just 1. So at index 1, we can just put in 1. For 3, let's do the same thing. So for 3, we have 2 multiplied by 1. That is the product. So here we'll have 2. For 4, it will be 3 into 2 into 1, which would be 6. Now what would be for the one side? So what is left to 1? Nothing. So what do? We'll put a 0, right? No. We can't put in 0 because, as I said, we are going to multiply the left hand side with the right hand side. Whenever you use 0 to multiply, the result will always be a 0. We can't afford that. So what we are going to do now is just have a 1 here. So if there's nothing, there's 1. That will help us in multiplication. Now what we have to do is calculate the right hand side. So let me just erase this off so that we have a better understanding, and I can't seem to get rid of it, so I won't. Now what I want to do is calculate to the right of 3, what is the product? To the right of 3, there's just 4. So I'll just put in 4. To the right of 2, there's 3 into 4, which is 12. To the right of 1, there's 2 into 3 into 4, which is 24. And to the right of, let's say, 4, there's nothing, so we're going to put in 1. And now we can just multiply each of these elements. And the answer will be 24, 12, 4 into 2 is 8, and 1 multiplied by 6 is 6. So that is our result, and it matches with the result that's present over here. But now there's a problem. Here there's a follow-up question of, can you solve the problem in O of 1 extra space complexity? The first instinct to me is no, I can't. I need the output array. Without the output array, how am I going to return to you an output array? And it does say that the output array does not count as extra space for space complexity analysis. So okay, I can just have one array. I have to get rid of this particular thing. The LHS and the RHS need to go away. Or in other words, what I need to do is combine the LHS and RHS process in one result array. And this seems quite doable, because this seems like a process that is done for our readability. If we remove our readability, just do everything in one array, it seems quite possible, but we'll have to figure out how to do that. So let's get started with that. Let me remove all of these things. So there we go, bye-bye. Also, I'll just try to remove this because it's a bit annoying to have them. And yeah, I'm finally able to get rid of them. Cool. So now what I need to do is find out the result array, and I only have one result array. Now what I'm going to do is use the same approach, but treat result as first a left hand side product place, and then treat it as a right hand side product place. What I mean by that is, initially I'll go from the beginning of the array till the end of the array, calculating all of the left hand side products. Then I'll go from the right hand side to the left hand side, from the end of the array to the beginning of the array, and just multiply everything. So what I'm doing here is first calculating all of the left hand side products. Then when I go from the right to the left, I'm finding out the right hand side products and multiplying them in the results array as well. Let's go over it one by one. So first of all, what is left to 1? We decided that it's going to be 1. So the left hand side product of 1 is 1. I'll keep track of another variable here called prefix. Prefix means all of the products on the left hand side. Okay. So 1 is the product we have now. Then we have 2. 2 multiplied by 1 is going to give us 2. So 2, actually never mind. I made a mistake here. It shouldn't be 2 multiplied by 1. Actually, it would be 1 multiplied by 1. That's because we had just pulled out a 1 from nowhere. We just put it in, and now we need to get the left hand side products of 2. So left hand side product of 2 is going to be this 1 multiplied by 1. So we have 1 now. After that, we calculate the left hand side products of 3. And left hand side product of 3 is going to be 2 multiplied by 1, which is 2. And then the left hand side product of 4 is going to be 3 multiplied by 2, which is going to be 6. And now the result contains all of the left hand side products. Now what I need to do is go from the end of the array to the beginning of the array, so that I find out all of the right hand side products. But remember, I only have this result array. So what I'll do instead is, now to the right of 4, I have just 1. Now what I'll do is just multiply this 6 by 1. Cool. So it remains 6. And that formalizes our answer that the last element is going to be 6. After that, I'll just do 4 multiplied by 1. So now I'll just have 4 into 1, which is 4, and then I multiply it with this 2. Because remember, what this postfix is doing, this variable that we have, what it's doing is it's trying to keep track of all of the products on the right hand side. And then we need to multiply it with the left hand side products that are already available in the result array. So what we do is multiply this 4 with this right hand side product. So we have 4 here, and then we take this 4 and multiply it with 2 to get the final result. So this 4 multiplied by 2 is actually the right hand side product multiplied by the left hand side product, which gives us 8. Cool. So let me just ensure that we have the right things in place. I'll update the variables. So I'll erase this off. Now our answer is 4 here. And this is no longer 2. This is 2 into 4, which is 8. After that, we'll go to the next thing. We need to figure out the product of elements to the right of 2. We already have 4. We need to multiply it with 3. So we have 3 into 4, which is now 12. And then I multiply this 12 with this 1. So I get 12 now. And finally, all of the product of elements to the right of 1, which is 2 multiplied by whatever we have here. So we have 24 now, and 24 multiplied by 1, which is 24. And this is how we get the result array. Cool. I know the left and right segregating it makes it more readable and understandable, but this is just more efficient because now we have O of 1, considering we are not using output array as the result array. All right. So the very first thing I'm going to do is pre is equal to 1. This variable keeps track of all of the elements that are before and keeps track of the left hand side products essentially. Okay. So if you remember, when we go from 1 to 4, from the beginning to the end, we're trying to calculate the left hand side products, right? So all we're doing is, well, initially we had 1, so we just put in 1 here, and after that we do 1 into 1, put 1, then 2 into 1, 2, then 3 into 1, or sorry, 3 into 2, which is 6. This is how we get the array. So this variable will keep track of all of the left hand side products. If you want, you can just make it left hand side products. That would be a better understanding, I guess. And then we can go over all of the elements in this nums array. Correct? But that's not what I'm going to do. Or actually we can do it. I don't mind it. After that, we can just say that, hey, we have a result array. Let's create it. So we have result is equal to an empty list. Then I can just have result at I, right? Because I want to set it at a particular index. Result at 0 will be set to something. Result at 1 will be set to something. That's why I was a bit hesitant to use this. Instead, what we are going to do is for I in range of length of nums. Now I have access to the index, and that result at I is actually going to equal to the left hand side products. Then I'm going to update the left hand side products, which is equal to left hand side products into, and I'll just pass in, let's say, the nums at I. So what have I done here? What I've done is, let's start scratch again. We'll just fill it in as and when we go ahead. Cool. So actually, let me just remove the entire thing. The array was 1, 2, 3, 4. So we have 1, 2, 3, 4 here. So this is the result array. Result at, what we have done is left hand side products is 1. Then I've said that result at 0 in the very first iteration is going to be 1. Cool. So I just take this value, put it here, and then move on. the left hand side products is now equal to left hand side products multiplied by nums at I. So it's 1 multiplied by nums at I, which is nums at 0, which is 1. So 1 into 1, which is equal to 1. After this, we go to the next iteration. So we have 2 now. So we just take element to the left, which is, well, we already know 1. We put that in because we have specified here result at I is equal to left hand side products. So we have this here, and then we multiply that variable left hand side products into nums at I. So now this is 2. In the next iteration, we can put 2 over here and then multiply this 3 with 2, which is going to be 6. And then we can put in 6. We update this 24 variable, but we do nothing with this variable. This is of no use. So what we have done is essentially we are doing kind of a late product of this left hand side products, so that, you know, we only get everything except this nums at I. Cool. So now we have this much. Now we want to do a right hand side products. So I'll create a right hand side products, which is going to equal to 1 as well, because we decided that if there's nothing to the right of 4, there's going to be 1. And then I can do for I in range of length of nums, correct? Nope. What we want to do is go from length of nums minus 1 till the end of the array in the reverse direction. The reason I've put length of nums minus 1 is because we want to start from the end of the array. The end of the array is going to be whatever is the length minus 1, because array indexing starts from 0. So if we have 5 elements, we want to start from the 4th index. So that's what we have done here. And we go till -1 because we want to go till the end of the array. And in Python, if you specify the second argument here, it's going to be not included. When you do for I in range length of nums, what we are doing is going till the end, discluding the length of nums element. So the 5th element will not be included. The same thing goes over here. We are not including -1, but we are going till -1. So 0 is including, -1 is not included. And -1 just tells you that we want to go in reverse direction. And now what we can do is result at I multiplied equal to the right hand side products. So here we are just multiplying everything, right? So we have a 1 here. So what we do is 4, or actually we just take the 1 and multiply here, and then we do 4 into 1. So now the 4 is updated. So just like before, we are going to have right hand side products is equal to right hand side products multiplied by the nums at I. And actually, I don't think it's going to be nums at I, because what we are trying to do is, let's say there's 1. So we do just 1 here. So 1 multiplied by 6, that's there. Then we multiplied 4 by 1. So we get 4 here. And then we multiply with 2. So actually it is nums at I. Cool. After that, we will return result. And we are done this way. So let's test it out. We get an error saying result at list assignment index out of range. And actually this error exists because we're trying to access result at 0, for example, but nothing is initialized in result. So we are just going to do 1 multiplied by the length of nums. And I think that should work out. So let's run it again. And it works out. I'll submit. And it's done. The time complexity of this is O of n. The space complexity is O of n technically. But if we don't include this as the, the space complexity, we can, if we consider this as O of 1, then it's O of 1. Because it's given in the follow-up, right? Cool. Now I'll again like to go over this solution because I know it can be a bit tricky. So if you've understood it, feel free to quit. But yeah, let's say we had this particular thing, which is 1, 2, 3, 4. So what have we done? We keep track of a variable that is kind of a left-hand side product variable, okay? Initially, it is set to 1. And then we create another variable, which is the result array. In the first iteration of the for loop, what we are doing is, like in the first for loop, we are just going from the start till the end. And then we are trying to figure out what is going to be the product on the left to each of the elements. To the left of 1, there's nothing. So we just take this 1 and put that in. After that, we multiply this 1 with this one. The reason we multiply this one and this one is because we want to find out what's left of 2. So what are the product of elements to the left of 2? And the only way to do that is keep track of the product in another variable, and as we move ahead, we update this variable. So now we just update this variable very easily by saying 1 into 1. Whatever is the existing value, multiply it with this particular value, whatever value we were on. So now we have 1, or actually let me change the color, which is 1. Cool. Now in the next iteration, we just take this value, put that in. So we have 1 here, and then we take this 2 and multiply it because we need to find out the product of elements to the left of 3. Because in the next iteration, we'll reach 3, right? So we just take this 2, multiply it with 1, and the answer is, well, 2 here. So let me just go ahead and have 2. Now I'll just drop in a 2 here again. And then I do 3 into 2 because element product of elements left to 4. So I have 3 into 2, which is 6. And now I'll just update this to be 6. And then finally, I just put that in. Then we do 4 into 6, which is 24. And now the loop ends. We don't have to put in 24 again because, well, the loop ended, right? We went from here to here. And this loop first assigns the value and then multiplies. And it does it for this particular reason. We have to calculate this first. We have to assign this first and then only calculate the left-hand side product. Because we don't want to include the element itself. If we first multiply, what we are doing is calculating the product itself as well. If I do this, what I'm doing is left-hand side product is equal to left-hand side product into nums at I. So if I'm on 2, what I'm doing is 1 into 2. I'm including 2. I don't want to include 2 in the very first try because then I'm doing result at I is equal to left-hand side products. No, I'll just assign first and then multiply it. After that, we go in the reverse direction. We go from the end of the array to the beginning of the array. So now we create another variable, which is the right-hand side products. That is also initialized to 1. Then we multiply these both together. We have 1 into 6, which is 6. After that, we multiply this 4 and 1. Because again, we're doing the same thing as the left-hand side product. We first multiply. By the way, remember here we were assigning, just assigning. Here we are multiplying and then assigning. The reason we're doing that is because we're trying to multiply everything, right? In the first instance, there's nothing. Even if you do multiply equals, it wouldn't really matter because everything is 1, right? The result array is all ones initialized. Now what we are trying to do is just, essentially do the same thing, but this time we have variables within result at I. So we are multiplying. So 1 into 6 is done, which is 6. Then we do 4 into 1. So we update this to be 4 and then we do 4 into 2, which is 8. So this keeps track of all of the elements to the right side, their products, and then we multiply it in the result variable. All right. And then we keep doing it. So we have 2 into 4, which is, or actually I don't remember what was it. So we have 4, then we have 3 into 4, which is 12. Then we take this 12, multiply it with 1. So we have 12 here. And then finally we have 1 into, or actually 2 into 12, which is 24. Then we do 24. And then we have 1 into 24, which is 24. But we do nothing with this value because we are done with the loop. Then we return the result and it's there with us. So yeah, that is the solution. I'll just submit once again to ensure everything's working correctly. And yep, it is.